Hello everyone, I'm back with two questions in this video. These two questions are very bright for your mind. It will give you a lot of learning about the probability, the fundamental concept of probability. The first video that the first question that you have to see is on your screen. Two persons are sitting in a room. It is known that one of them is a man. What is the probability that other is also a man? And second question is coming very soon. But to first understand that there are two persons, both are sitting in a room. It is known that one of them is man. Now, which one of the person is man is not known. It is just known that one of them is man, and the second is this. Two persons are sitting in a room. When one of the person come out of the room, it is known that it is found that he is a man. Now, what is the probability that other who is still sitting in the room is also a man? Now, these two questions looks very similar. Looks in fact very not similar. You can say this sounds the same questions said in two different ways. This is just a game. This is just a you can say twist of the language. But let's see what happens. In the first case, that the two persons are sitting in a room, one of them is a man. Let's say the persons are P1 and P2. We don't know the gender of the P1 and P2. So, what can be the sample space of this random experiment that the two persons are sitting in a room? Let's say the persons are P1 and P2. And P1 can be man, P2 can be man, P1 can be a woman, P2 can be a man, or P1 can be man, P2 can be a woman. So these can be the three possible cases when one of them is a man. Both cannot be women, so that case is ruled out. And therefore sample space consists of these three ordered pairs of men and women, gender of person P1 and gender of person P2. And event says that what the probability that both are men, so there is only one element in the event. And as you can see here, that all three elements are equally likely. They are equally likely to occur. They are mutually exclusive also and exhaustive also, and therefore the probability is equal to N by Ns, that is equal to 1 by 3. So this is very straightforwardly sorted, but sometimes I have seen students making mistake in this question also. Some of them says that is 1 minus 1 by 4. That is wrong. Now coming to the second question. So one of them comes out of the room and it's found that he is a man. What is the probability that other person is also a man? So see, when the first person, let's say that there are two persons, P1 and P2 sitting inside the room, and one of them is called out. Now any one of them can come out of the room when one person is called out of the room. So suppose that P1 is a lazy person and P2 is a little quicker, and when one person is called out, P2 quickly comes out of the room and it is found that P2 is a man, right? So now it is for sure that the person P2, the gender of P2 to be a man is 100%, and therefore probability that the person P2 is a man is equal to 1. Now everything, the suspicion, the suspense, the uncertainty that still remains is all about the person P1 who is still sitting inside the room, because as I said that he is a lazy person, and the second person in this case is the person P1, and we have to find that the person P1 is also a man. Now when it is known that P2 is a man and P1 is a person, assuming that he is of course a normal person, so only two gender is possible, so there is equal chance that the person P1 can be a man also, a woman also, and sample space might be a man if you form on the first person, it can be a man woman, or taking both together man man and man woman, and the event has only one element, that is both can be a man. So therefore In this case also they are mutually likely, equally they are mutually exclusive, equally likely and exhaustive cases. Therefore, in this case probability is equal to 1 by 2. So as you can see that in both question, in the first time looks same but answers are different.